In this session, we're going to talk about another test. We have seen a lot of tests so far, and the limit comparison test is the limit form of the comparison test. As you have seen, when you use the comparison test, comparing two series is not going to be easy most of the times. You need to find a series which you know if it is convergent or divergent. Also, you need to compare them. And limit comparison test will give you another way to find the convergency without comparing. So it is easier than comparison test. Let's look at what it says. Let's say we have two series, AN and BN, and then we know they are both positive term series, which means this, right? So they're both positive term series. Then I need to take the limit of the ratio of these two series general term. And then after finding this ratio, as you see, I'm taking the limit of a sequences, right? That's why we learned a lot of theorem about the sequence of limits of sequences. If this limit is bigger than 0, if this limit is bigger than 0, but it is not equal to infinite, it is between, 0 and infinite, then both series are convergent or divergent. So they have the same characters, guys. Secondly, if this number is equal 0, then if Bn is convergent, then you can say that An is convergent. I need to write actually the series, not the sequences, since these are just the general term. We need to keep the correct form. But L could be equal infinite. Then we can say that if Bn series is divergent, then An is also divergent. Okay, that's what we call the limit comparison test. As you see, I'm comparing under a limit, and I need to find that limit using the sequence limit theorems. Let's look at some examples. The first example is going to be similar what we have done in the comparison test section. I have a rational polynomial type of series, like this one, and I want to use limit comparison test. Why? You can ask this question, why don't you use, some other test? Of course, you can go with the other tests, like the integral test, comparison test, but they will not be easier than the limit comparison test, especially if you have such a complicated case. Look at that. If you want to take the integral of this function, similar to, which is same with this general term, taking integral is so hard for this general term. Also, if you want to compare, this series by another series, since you have some addition term here, the comparing with another series is not going to be easy. If you look at the n-term test will give you 0, and it is inconclusive, so I can't use it. So the only alternative test would be limit comparison test. Let me try to use it. So it imposes us, I need to figure out what the second series is. As I was choosing the second series in comparison test, I'm gonna use the same technique to choose the Bn series, guys. When I choose my Bn series, since I need to use a second series for my limit comparison test, I'm gonna use the highest degree term. Look at that, guys. Highest degree term in my original series. Okay? So if I choose either with the coefficient or without coefficient, it's up to you. I'm gonna go without coefficient. N squared over n cubed. I can choose in this way. So it is gonna be equal 1 over n type of series, right? So let me try it, okay, to see if it works. Also, do I know if this series is convergent or divergent? Yes, I know, since this is my harmonic series, right? Harmonic series, and it is divergent. I need to compare these two series using the limit comparison test in this way. My AN is this one, and my BN is this one. Okay? This is my BN, this is my AN term, general term. Okay, how can I take this limit? First of all, I need to flip the BN. If I flip it and then if I multiply by the term that I have on the top, that would be equal to this. 3n cubed plus 4n will be same. But if I multiply n by n squared, it's going to be n cubed plus 5n squared. Okay, when I look at the sequence limit, it is easy one. Since I can just take the coefficient of the highest term, or you can go with the L'Hopital rule since it is undetermined case, infinite over infinite. But I'm just gonna go with the simple way, and then when you solve this type of problem, you can do the same thing. Look at that, 1 over third. How did I get this result? Since I know, look at that, when I have the same degree, I can just use my coefficient. Okay, I got the result. This is my L. And then in this example, L is bigger than 0. If L is bigger than 0, what am I gonna say? They are both convergent or both divergent. And then since Bn, which is this one, is divergent, then I can say that my AN is also divergent, right? Because of limit comparison test. That's how I use the limit comparison test. Now, let's look at another example, guys. Second example, 3n minus 2 over 5n to the 4 plus 4n minus 1. Is it convergent, right? That's the question. How am I going to choose, right? That's the step one. Step one, choose the Bn, the second series you need to use in limit comparison test. I'm going to go with the highest term in my rational type of general term, n and n to the fourth, which is equal 1 over n cubed. Is it convergent? Yes. Since p is bigger than 1, p is equal to 3 bigger than 1, it is convergent because of p-test. Then now I can start comparing these two series. Step 2, I need to take the limit of these two series under this limit. I'm just using the general term of them. My Bn goes to the bottom, and then my n goes to the top. 5n to the 4 plus 4n minus 1. And then look at that. I'm going to use the same algebra technique. When I multiply at the top, after flipping the second term, it's going to be equal 3n to the 4 and minus 2 n cubed. I have 5n to the 4 plus 4n minus 1 in the bottom. I will use the same technique. I have n to the 4 and then they are the highest degree term, and my limit is going to be equal to 3 over 5, which is bigger than 0. That's why what I can say, they have the same character. So if Bn is convergent, my An is also convergent. Do I know if it is convergent? Yes, my Bn, right, was this one, is convergent. Then I can say that my original series is also convergent. It was 3n minus 2 over 5n to the 4 plus 4n plus 1 is convergent because of limit comparison test. The last example, let's look at some different type of term. Three to the n over 4 to the n minus 5. So we are asking the same question always, as you know, if it is convergent. So step one, as you know, you need to choose a Bn. But if you look at the general term is different than the others. That's why I need to be careful. When I choose something like that, I cannot use the highest term, so there is no highest term in the bottom or in the top. What am I going to do? I might be using something like that. Let me try it. First of all, I need to know if this is convergent. Is it? This is geometric series. And I know that when I have the geometric series, R is going to determine if my geometric series is convergent or not. In this case, since R is equal to 3 over 4, which is less than 1, that is why this series is convergent, right? It is convergent. Then I need to compare using limit comparison test. So I'm going to take this limit using my An general term and my Bn general term. I should use some algebraic operation. 3 to the n times 4 to the n, and the bottom will be equal to this one, 12 to the n minus 5 times 3 to the n. This is also equal to 12 to the n, guys, right? So let me write it down in a better way. 12 to the n and 12 to the n minus 5 times 3 to the n. Okay, what else? To be able to find this limit, I should simplify more. How am I going to do that? As you see, I have the 12 to the n. If I take this out, I may cancel the term on the top. How am I going to do that? If I take the 12 to the n here, I have 1 here, and then I will have here the 3 over 12 to the n. 12 to the n goes away. What I have left here, 1 over 1 minus 5 times 3 over 12 to the n. Okay, can you please tell me now, when n goes infinite, this limit will go where? Since the term inside, look at that, there was another limit sequence, if you remember, right? If this number is less than 1, this limit goes 0, right? If this limit goes 0, then my overall limit is going to be 1. 1 is bigger than 0. That is why if Bn is convergent, then An is convergent. What was my Bn? Bn was equal to 3 to the over 4 to the n, which was geometric series, right? Geometric series. And then I know it is convergent. That is why, right? Your original series, which is this one, is also convergent because of limit comparison test.